Assalamualaikum warahmatullahi wabarakatuh and a very good day to my honorable judges. Today I'm going to explain on my invention with the title of Artificial Bone from Eggshell. My name is Associate Professor Dr. Mihanabi Ahmad Salimi and these are my team members. I am from the Nanotechnology Research Group, Geopolymer and Green Technology Center of Excellence here at University Malaysia Police UNIMED. So I would like to start with the problem statement. Eggshell or ES is an emerging abundant solid waste created from various sources such as poultry, homes, restaurants and food manufacturing industry. In Malaysia, about 642,600 tons of eggs are produced every year, and from this amount, a total of about 70,686 tons of ES waste is expected to be generated every year. This waste has potential for producing hydroxyapatite with the chemical formula of Ca10PO4 6OH2, a major component found in bone and teeth. Hydroxyapatite is an excellent material used in bone repair and tissue regeneration. Artificial bone refers to bone-like material created in a laboratory that can be used in bone grafts to replace human bone that was lost due to severe fractures, disease, etc. Bone fracture, which is a complete or partial break in the bone, is a very common condition. Hydroxyapatite, which is one of the most stable forms of calcium phosphate, makes up about 60 to 65% of the bone. The structure of hydroxyapatite is very similar to that of the original bone. This is the method for synthesis of hydroxyapatite from eggshell. Firstly, eggshells were rinsed with water and dried in an oven. Then dry eggshells were crushed into powder using a grinder. Next, powder was calcined at 900 degrees Celsius for 3 hours to decompose calcium carbonate into calcium oxide. Then calcined eggshell was milled using a planetary ball mill with dicalcium phosphate dihydrous to undergo mechanochemical activation. Lastly, milled powders were heat treated at 1100 degrees Celsius to obtain pure hydroxyapatite. These are the characterization analysis that we carry out, namely FTR, XRD, and SEM. All the results show that the synthesized hydroxyapatite is in its pure form. We also had double-checked it with the data of the commercialized hydroxyapatite. We also carry out compressive strength testing as to make sure that the synthesized hydroxyapatite will able to perform its purpose for the artificial bone application. The result that we obtained for compressive strength are between 9 to 11, which corresponded well with the cancellous bone compressive strength of about 9 to 11. In terms of novelty, this is the first reported of hydroxyapatite nanoparticle synthesis with contour parameters by mechanical method which produce uniform and small particle size. I had a patent filing for this invention. In terms of publication, I had published some articles in reputable journals such as Powder Technology, which is a Q1 journal, and also at Q2 and Q3 journals. I also had published in a book chapter. For commercial potential, this inorganic biomaterial has the potential for the artificial bone application at the global level with high impact from the perspective of healthcare. We had carried out cooperation with University of Science Malaysia and also Clinical Research Center at Hospital Tuanku Fauzia for further testing on actual patients with bone fracture. As conclusions, eggshell or ES is a natural waste produced in abundance yearly which can be transformed into hydroxyapatite powder for artificial bone application. This avoids of using synthetic chemical formation to produce artificial bone, which might be harmful to humans. So this invention can be considered as a green invention. Further testing of this biomaterial on actual patients with bone fracture will underline its benefits to the whole world. With a costing of just 5 ringgit per 100 gram of hydroxyapatite, it will benefit a lot of people. So, from our waste, we can transform it into a useful biomaterial product. So that's all my presentation. Thank you for listening and I hope you all have a good day. Thank you.